No, you cannot use the existing temporary circuit to light up any 2x4 lights. The temporary circuit is only intended to provide temporary power during construction and is not suitable for permanent lighting. There are several reasons for this. Firstly, safety. Temporary circuits are typically not installed to the same standards as permanent circuits and may not meet the necessary safety requirements for lighting. Secondly, overloading. Adding additional lighting to the temporary circuit could overload it, which could cause a fire hazard. Thirdly, code violations. Using a temporary circuit for permanent lighting would violate electrical codes. To safely light up the 2x4 lights until your permanent service is installed and inspected, follow these steps. 1. Disconnect the temporary circuit. Turn off the power to the temporary circuit and remove it from the electrical panel. 2. Test your splices. Make sure all your splices are secure and properly insulated. 3. Install a temporary lighting fixture. Use a temporary lighting fixture, such as a work light, that is designed to be connected to a 120-volt outlet. 4. Connect the temporary lighting fixture. Plug the temporary lighting fixture into an outlet that is connected to a different circuit from the one you will be using for the permanent lights. 5. Turn on the temporary lighting fixture. Turn on the temporary lighting fixture to provide illumination while you wait for your permanent service to be inspected and installed. Once your permanent service is installed and inspected, you can then connect your 2x4 lights to the appropriate circuit and remove the temporary lighting fixture. Temporary power systems are designed to supply electrical power for a limited time during construction, renovation, maintenance, or emergency situations. These systems often differ significantly from permanent electrical installations in terms of design, materials, and installation practices. It's crucial to understand the limitations and potential hazards associated with temporary power to ensure safe and code-compliant electrical work. Overloading circuits is a common cause of electrical fires. Temporary circuits are often sized to handle a specific load, and adding more devices or fixtures can easily exceed the circuit's capacity. This overload causes excessive heat in the wiring and components, increasing the risk of insulation breakdown and fire. Temporary wiring methods often involve the use of extension cords, flexible cables, and surface-mounted wiring, which are more susceptible to damage and environmental factors than permanent wiring systems. These factors can compromise the insulation and expose live conductors, creating shock and fire hazards. Electrical codes, such as the National Electrical Code, NEC, establish specific requirements for temporary electrical installations to ensure safety. These requirements cover aspects like grounding, overcurrent protection, wiring methods, and DFCI protection. Violating these codes can result in fines, project delays, and, most importantly, increased safety risks. Ground fault circuit interrupters, DFCIs, are essential safety devices that protect against electrical shock by quickly interrupting a circuit when a ground fault is detected. GFCIs are often required for temporary circuits in damp or wet locations to minimize the risk of electrocution. Before energizing any temporary circuit, it's essential to inspect the wiring, connections, and protective devices to ensure they are in good condition and properly installed. This inspection should include checking for loose connections, damaged insulation, and proper grounding. Regular inspections should be conducted throughout the duration of the temporary installation to identify and address any potential issues. Proper grounding is critical for electrical safety. Temporary electrical systems should be grounded according to code requirements to provide path for fault current and minimize the risk of electric shock. Grounding electrodes, such as ground rods or connections to the building's grounding system, should be properly installed and tested. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect circuits from overloads and short circuits. It's crucial to ensure that the overcurrent protection devices are correctly sized for the temporary circuit and that they are functioning properly. Using extension cords can be convenient, but they also pose several risks if not used properly. Extension cords should be sized appropriately for the load they are carrying and should be inspected for damage before each use. Avoid overloading extension cords and never run them under rugs or through doorways where they can be damaged. Temporary lighting should be installed in a way that minimizes the risk of electric shock and fire. Use only approved lighting fixtures and ensure that they are properly grounded. Protect lamps from breakage and avoid using exposed wiring. All electrical work, including temporary installations, should be performed by qualified electricians who are familiar with electrical codes and safety practices. Using unqualified personnel can lead to dangerous installations and increased risks. Before starting any electrical work, always energize the circuit and verify that it is energized using a voltage tester. Follow lockout-tagout procedures to prevent accidental re-energization while work is in progress. Wear appropriate personal protective equipment, PPE, such as insulated gloves, safety glasses, and appropriate clothing when working with electrical systems. This PPE helps protect against electric shock, arc flash, and other hazards. Never work on energized electrical equipment unless it is absolutely necessary and you have been properly trained and authorized to do so. Working on live equipment significantly increases the risk of electric shock and arc flash. Use insulated tools when working on only energized electrical equipment. Insulated tools help protect against electric shock by providing a barrier between the user and live conductors. Before making any connections, ensure that the power is turned off at the source. Double check with a voltage tester to confirm that the circuit is de-energized. Make sure all connections are tight and secure to prevent loose connections, which can cause overheating and arcing. Use appropriate connectors and wiring methods for the application. Temporary wiring should be secured to prevent it from being damaged or creating a tripping hazard. Use cable ties, straps, or other appropriate methods to secure the wiring. Avoid running temporary wiring across walkways or in areas where it can be easily damaged. If wiring must cross a walkway, protect it with a suitable cover or ramp. Keep temporary electrical equipment and wiring away from water and other liquids to prevent electric shock and equipment damage. Use weatherproof enclosures and connectors when working in damp or wet locations. Be aware of the location of underground utilities before digging or driving ground rods. Contact your local utility company to locate underground utilities before starting any excavation work. Train workers on the hazards associated with temporary electrical installations and the safe work practices that should be followed. Ensure that workers understand the importance of grounding, overcurrent protection, and GFCI protection. Post warning signs to alert workers to the presence of temporary electrical hazards. These signs should clearly identify the hazards and the precautions that should be taken. Develop a written safety plan that outlines the procedures for installing, maintaining, and removing temporary electrical installations. This plan should be reviewed and updated regularly. After the temporary electrical installation is no longer needed, remove it promptly and properly. Dispose of any damaged or worn materials in a safe and environmentally responsible manner. Electrical safety audits can help identify potential hazards and ensure that temporary electrical installations are in compliance with applicable codes and standards. These audits should be conducted by qualified professionals. Maintain records of all temporary electrical installations, including the dates of installation inspections and maintenance. These records can be helpful for tracking the performance of the system and identifying potential problems. Stay up to date on the latest electrical codes and standards. Codes and standards are constantly evolving, so it's important to stay informed of the latest changes. There are several types of temporary wiring methods that are commonly used in construction and industrial settings. These methods include temporary power cables, flexible cords, and open wiring on insulators. Each method has its own advantages and disadvantages, and the best method will depend on the specific application. Temporary power cables are typically used for heavy-duty applications such as powering large equipment or machinery. These cables are usually constructed with a durable outer jacket and are designed to withstand harsh environments. Flexible cords are commonly used for powering portable tools and equipment. These cords are flexible and easy to handle, but they are not as durable as temporary power cables. Open wiring on insulators is an older method of temporary wiring that is still used in some applications. This method involves running insulated conductors on insulators mounted to walls or ceilings. Open wiring on insulators is relatively inexpensive, but it is not as safe as other methods of temporary wiring. When selecting a temporary wiring method, it is important to consider the following factors: the type of load that will be powered, the environment in which the wiring will be installed, the required ampacity of the wiring, and the budget for the installation. In addition to the general requirements for temporary electrical installations, there are also some specific requirements for temporary lighting. Temporary lighting should be installed in a way that minimizes the risk of electric shock and fire. Use only approved lighting fixtures and ensure that they are properly grounded. Protect lamps from breakage and avoid using exposed wiring. Temporary lighting should be controlled by switches or other devices that are readily accessible. The switches or devices should be clearly labeled to indicate which lights they control. Temporary lighting should be inspected regularly to ensure that it is in good condition and that it is functioning properly. Any damaged or worn lighting fixtures should be replaced immediately. The NEC provides detailed requirements for temporary electrical power and lighting installations in Article 590. This article covers the use of temporary wiring methods, grounding, overcurrent protection, GFCI protection, and other safety requirements. Following the NEC requirements is essential for ensuring the safety of temporary electrical installations. The Occupational Safety and Health Administration (OSHA) also has regulations that apply to temporary electrical installations. These regulations cover topics such as lockout tagout, personal protective equipment, and safe work practices. Complying with OSHA regulations is essential for protecting workers from electrical hazards. Regular maintenance is essential for ensuring the safety and reliability of temporary electrical installations. Maintenance tasks should include inspecting wiring, connections, and protective devices, testing GFCIs and other safety devices, and replacing any damaged or worn components. Proper planning is essential for ensuring the success of temporary electrical installations. Planning should include identifying the loads that will be powered, selecting the appropriate wiring methods, and developing a safety plan. Taking the time to plan ahead can help prevent problems and ensure that the temporary electrical installation is safe and reliable. Remember to disconnect the temporary circuit. Turn off the power to the temporary circuit and remove it from the electrical panel. Test your splices to make sure all your splices are secure and properly insulated. Install a temporary lighting fixture that is designed to be connected to a 120-volt outlet. Plug the temporary lighting fixture into an outlet that is connected to a different circuit from the one you will be using for the permanent lights. Finally, turn on the temporary lighting fixture to provide illumination while you wait for your permanent service to be inspected and installed. Once your permanent service is installed and inspected, you can then connect your 2x4 lights to the appropriate circuit and remove the temporary lighting fixture.